Hello guys, welcome back to my YouTube channel on Sagacious. So in this video we're going to be talking about vectors. So once you hear the word vectors in physics, what comes into your mind? So vectors, we are just talking about force. So if you hear vectors, just say force. You're talking about force. So we have two types of vectors. We have the scalar and the vector quantity. So what is the scalar quantity? Scalar quantity is a quantity that has magnitude but has no direction, and a vector quantity is a quantity that has both magnitude and direction. So I mentioned two things here: magnitude and direction in scalar quantity. So what is magnitude? But since they said scalar quantity does not have magnitude, so I'm going to eliminate magnitude for now and talk about direction. So direction, force is pushing or taking the objects to. So let's talk about the vector quantity. A vector quantity is a quantity that has both magnitude and direction. So the vector quantity has magnitude. So what is this magnitude? Magnitude is the size or extent of something. Magnitude is the size or extent of something, or amount or degree of a quantity, the amount of degree of a quantity, and direction. So we have resultants. Resultant is the product of the words, the force in magnitude and direction. So let's talk about resultant. Resultant force is a single vector that represents two or more force at a point, both in magnitude and in direction. This is what I just said. Resultant is just the force, the single force due to two or more forces acting at a point. So let's talk about the addition, subtraction, and zero resultant. So we have the addition vector. Addition vector occurs when where two forces are moving or acting as objects in the same direction. So this is the object. So these two vectors, let me say 5 and 6. These two vectors, 6 here and 5 here. This is 5 Newton. Force is measured in Newton. This is 5 Newton. So these two vectors are acting at an angle in the same direction. So this is the object they are acting on. So this is addition vector because the resultant is a single force. So the resultant is 5 plus 6, which is equals to 11 Newton. So let's talk about subtraction of vectors. So if you talk about subtraction of vectors, this is when two forces are acting at an angle to each other. So this is the object, and here is 7 Newton, and here is 5 Newton. So these two objects are acting at an angle to each other. This one is acting this way, while this one is acting this way. So we call it the subtraction vector because this force here is bigger than this one. The 7 Newton force is bigger than the 5 Newton force. So for this force, where will this object move? This object will move in this direction. The object will move in this direction because this force must overcome this force here. So for this force to overcome this force, this is 7 minus 5, which is equals to 2 Newton, which means that this object will be moving, this object here will be moving in this direction with a force of 2 Newton. So let us talk about zero resultants. This is a force, or you can also meet these zero resultants mostly on equilibrium of rigid body, and let's talk about it here. So zero resultant is when two forces are acting at an angle to each other, or when two equal forces are acting in opposite direction, or when the algebraic force acting on a body is equals to 0. So this can occur when here is what 5 Newton, when a force of 5 Newton acts in this direction and a force of 5 Newton acts in this direction. Here is the east direction and here is the west direction. So this angle acting at an angle opposite to their direction, they are equal. So we have 5 minus 5, which is equals to what? 0. So this object here will be in equilibrium. Equilibrium is when an object is what? In motion, but like equilibrium is when an object is being acted by a force but it's maintaining its speed, or is moving in a particular speed, or it has somewhere but many force is acting on it. this, we can also draw this diagram not only in this way. We can also say the north, east, west and south force. Let's say here is 5 Newton and here is 5 Newton. So if you're talking about the algebraic force, or the algebraic force of this object, the total force, if you hear algebraic force, I'm talking about the total force acting on this object is equals to 0, because 5 cancel 5 will give us 0 and 5 cancel 5 will give us 0. So let's talk about the parallelogram law of vectors. So the parallelogram law of vectors, from here we are going to derive the formula which we are going to be using solving the resultant. So what is the parallelogram law of vectors says? So the parallelogram law of vectors states that when two vectors are acting at an angle to each other from a point, the vectors are represented in magnitude and in direction by the adjacent side of the parallelogram, and their resultant is represented in magnitude and in direction by the diagonal or drawn from the same points. Let me repeat this law. Parallelogram law of vectors states that when two vectors are acting at an angle to each other from a point, the vectors are represented in magnitude and in direction by the adjacent side of the parallelogram, and their resultant is represented in magnitude and direction by the diagonal or drawn from the same points. So from here, let's say here is angle theta. So here is the resultant. Remember, resultant is what? The product of when two forces are acting on a point. So the object will move with a single force. That single force is called what? The resultant. Let me draw a diagram for you to understand this thing. This is an object and two forces acting horizontal and vertical. So these two forces acting on this object in horizontal and vertical form. So this object will now move with a single force. This single force is called the what? The resultants. This object will now move with a resultant force, which is this. So this is how we got this diagram. So from here we can draw this diagram as this way, where here is the resultants, here is the two forces. Let's say the two forces P and Q. And okay, to reduce the rate of confusion, we can also draw it like this. So where here is the resultant, here is P and here is Q. As you can see here, just look, this is the exact diagram of this. So in mathematics, if you are asked to find the hypotenuse is equals to hypotenuse squared, which is equals to P squared plus what? Q squared. So we are going to apply it here. If you are asked to find the resultant force, it will now become R squared is equals to P squared plus Q squared. So from here we can now go ahead and derive our formula. So the formula will now become, the resultant is R squared is equals to P squared plus Q squared minus 2PQ cos what? Cos theta. And this theta is equals to what? 180 degrees. So this is the formula for parallelogram law of vectors. So let's practice some questions, or you can go ahead and solve with the formula. So calculate the resultants of two forces acting at an angle theta. Here is theta of 30 degrees. So first we're going to write our formula. So our formula is what? R squared. We are asked to calculate the resultants. That is why we are using this formula, R squared. But if we are asked to calculate the resultant and the magnitude, I will tell you something. So R squared is equals to P squared plus Q squared minus 2PQ cos 180 minus theta. So this is the formula. But you should notice something. They didn't give us the force, so I'm going to add the force. So let's say the two forces is 5 Newton and 12 Newton. We can now go ahead and solve. So R squared is equals to, the first force is 5 Newton, which is 5 squared, plus the second force is 12 Newton, which is 12 squared, minus 2 times P is 5 times Q is 12 times 12 brackets cos 180 minus 30, because the degrees is 30 degrees. So r squared is equals to 5 squared is 25 plus 12 squared is 144 minus, in bracket, 2 times 5 times 12 cos 180 minus 30, we now have 150. So r squared is now equals to 25 plus 144, we now have 169 minus, so use your calculator and press 2 times 5 times 12 cos 150. See that we're going to have a negative. That is why I put this in a bracket. This bracket is very important for you to avoid confusion. So brackets 2 times 5 times 12 cos 150, so we have minus 103.9. So minus times minus is plus, so r squared is equals to 169 plus 103.9. so from here we now have r is equals to 272.9. Square root of 272.9 is now equals to 16.5 Newton. Question: calculate the resultant of two forces, 5 Newton and 12 Newton, acting at an angle theta 180. So solution: first, what is our formula? R squared is equals to p squared plus q squared minus 2pq cos 180 minus theta. So this is our formula. So we are asked to calculate the resultant, which is this, and we are given the two forces and the angle, so it's complete. So let's go ahead and solve what we are asked to solve. So r squared is equals to 5 Newton 5 squared plus q is 12, which is 12 squared minus, in bracket, 2 times 5 times 12, because this is our formula, 2 times p times q, and p is 5 and q is 12, so 2 times 5 times 12 cos bracket 180 minus 180. So we have 180 minus 180, so our cosista will be now equals to 0. So r squared is equals to 5 squared plus 12 squared minus 2 times 5 times 12 cos 180 minus 180, which is equals to 0. Now we have r squared plus 25 plus 144. 5 squared is 25, so we are going to write 25. So here is equals to plus 12 squared is 144, so we are going to write 144 minus, in bracket, 2 times 5 times 12 cos 0. We are going to have 120. So we're going to have positive 120, so this should be a positive 120. So r squared now be equals to 25 plus 144 will now give us 169 minus times plus is minus 120. So we now have r squared is equals to 49. So we now have the resultant being equals to square root of 49 is now equals to 7 Newton. So this is what I have for you in this video, and don't forget to like, subscribe and hit the notification bell for more videos like this. Thank you and goodbye.